In this tutorial, I'm going to show you how to use the basic local alignment search tool, BLAST. There are a couple different versions of BLAST. You may, if you're a biotech major, have used this in other courses. BLASTn will compare nucleotides to nucleotides. BLASTp will compare proteins to proteins. BLASTx, tBLASTn, and tBLASTx are going to use translations to compare nucleotides to translated proteins. Proteins to translate nucleotides or vice versa. So lots of great tools, all very helpful for doing things like primer design or figuring out what could a possible gene function be for a new genome that isn't annotated, for understanding sequencing data that you get, what kinds of things it could be a match to when it's not a perfect sequence. So this algorithm is going to give us, out of all of the data that's in the NCBI database, what are the best matches. So the first homework, the 1.4 homework, is going to ask you to do two kinds of BLAST searches. So rather than showing you step by step with the homework, in this video, I'm just going to show you how to do the two kinds of BLAST searches. So I picked a globin from fruit flies. So I just picked an accession number. You can cut and paste a sequence in here, but I always recommend putting the accession number if it exists, because you can easily make a mistake. You can't see the whole sequence when you paste it into a window, and you cannot get it all copied over. And when you get the accession number, you know that you're getting the latest one every time. Then I can pick what database I want to look, and I can specify an organism, or I can exclude models, or I can limit, or I can exclude uncultured environmental samples. So I'm going to exclude the uncultured environmental samples, and I'm only going to look for highly similar sequences. So I'm going to try to find something that's really similar to this, maybe in another fruit fly, but like in a different species, and be able to come up with something that can be like a nice comparison. So the BLAST search results, the amount of time that it takes will depend on traffic. So some days when you run it, it will take a little bit longer than other days, but usually a short sequence, so mRNA will run relatively quickly. So the query length that I put in was 1,000 nucleotides. So that's something that will run pretty quick. And now I can look at what the results look like. And I can look at it in a couple different ways. The first thing I'll do is the table, where it has a description, a scientific name of the species that the data comes from, a max score, a total score, query coverage. So if I put in 1,043 nucleotides, and it says it's 100% query coverage, that means the match was at least 1,043 nucleotides long. The E value, the percent identity, and the accession length, so like how long is the sequence, these are all things that are going to give me information about how good the match was. And in the quiz, the one I ask about is this percent identity. So we can scroll down and we can look for another sequence that is not perfectly identical to get more information about it. So if I click on it, I can actually see what the alignment looks like. And I can see that there's these long stretches of almost perfect matches, and then a couple places where gaps had to be introduced. And I can also copy this sequence to do the second kind of BLAST search. So if I don't know what will be a good match in the database, I'll often align the sequence not to an individual piece of data, but I'll align it to the database and find that huge table and get all of the search results. When I have two sequences that I want to compare, I don't need to waste time. And this is going to be a much faster search to just run one sequence compared to another. And it pops up almost instantly. And now I can get that same report, and I can see by clicking on this more details, what's the percent identity, 92%. Specifically, it's 888 out of 963 aligned nucleotides. You'll notice that number is lower than the query length. And that is also why if we look back at the table that the query coverage is only 92%. So you have all this great information. This tool works really fast when we're doing a pairwise alignment. It still works pretty fast when we're doing an alignment of a single sequence to the database and finding the best hits. And what your job in the quiz is just to understand what these search results mean and click around so that you can understand the navigation of the BLAST tool. Good luck, and let me know if you have any questions.